Hello, everyone, and welcome to another session of Me Programming Daily. I hope you had a lovely weekend. Today on the agenda, Dracon Render, and if you watched the last session, I think I finished this silhouette diagram, and I'm not going to lie, I'm pretty proud of doing it. It took us months to get here. However, looking at the code, I couldn't understand some of the parts after going back to them for the first time in weeks or months, namely the connected skewer blocks. I read the code during the weekend, and now I understand what's happening. And these connected skewer blocks are a type that lets you define a list of skewer blocks and potentially a connection at the end of this list to a non-natural ending of that list. So what it means is, if I can find a good example here, this would be one connected skewer block. Let's try to find it in the input. Wait for the bus. You probably can't see it, so let me zoom in. Sorry, wait for your turn. Wait for your turn. Wait for your turn. So here we have a good example of connected skewer blocks with just one action in the list. And instead of just going back to the skewer on which the fork or the question resided, we're going to ID 500, which is it your turn? So we're making a loop. So now I'm thinking, is this extra type needed? Maybe it isn't. But at the same time, I don't really have the appetite to refactor the code just to remove that type and replace it with just what even would be a good candidate for this. Let's see. Connected skewer blocks. Yeah, it would be maybe a tuple of, it will be a tuple of a list of skewer blocks and maybe AD. So is it worth doing? It's not here. It's not used here. So I think it's only used in, let's see, only in forks, I think. Maybe we do remove it. But at the same time, I think it would make sense to start formulating a syntax for this design language. So I'm having experimented with Dracon for a number of months now. I don't think I'm tempted to implement the whole language fully in this renderer. I am tempted to formulate my own design language with its own syntax that is inspired by Dracon, but much simpler. So I want that language to be useful to people who just want to, maybe not just, to people who want to create a flowchart, a Dracon-style flowchart, relatively easily, and I want to reach also non-engineering audience, because us engineers rely on a plethora of tools, some better, some worse, but there are not too many tools available for Dracon, specifically for Dracon that you want to use in the context of, say, writing a GitHub Markdown page. GitHub started supporting Markdown a while ago with all its types of diagrams, but Markdown does not have Dracon. I'm not saying I want to inject Dracon into that sort of niche and audience. What I'm saying is that I want this syntax and this design language to be accessible to a wide group of people, not necessarily only engineers. I do believe that we have a good opportunity here to start communicating using diagrams more. So let's maybe try to turn this, our diagram, into maybe a simplified syntax that then we would syntactically analyze, parse, and interpret as a diagram. So this session probably will be more what if than programming, but we shall see, I suppose. So I hope you have your fresh drink of choice ready. I have my coffee ready. And let's maybe figure out how a syntax for this could look like. If we were to start over with something brutally simple, the simplest possible diagram I can think of would look something like this. I was also briefly tempted to remove this from the type, but I think we can still live with it in favor of starting my work on simplified syntax for the input. And an action. Oh, it needs to be a collection of collections. Three with one. Yeah, something like this. So a syntax for this could look something like this. Title. Would just be text. No ID. Expected from the user. No block name. and in the middle, let's do ID optional. With ID1, something like this. And it needs to be a string. Oh, sorry. I can interpret this as a string later. So this is what a simple diagram could look like. The problems start when we start thinking about things like forks. Now let's try something more ambitious that has a fork. Just one fork is fine. And here we have the connected square blocks. This probably will not be exposed to the end user. And as complex as it may look, syntax like this will not be exposed to the end user. Let's try to render this. Just a simple fork. Every time a diagram just works, it just feels great. 1, 2, 3, 4. That's the height, and width is 2. Perfect. So let's try to figure out how this could look like. Do we really need this? No. And this can be an arbitrary number of white spaces. And now, I think we will not escape indentations. Well, that is 2. 2. So at the end of the day, it is a visual language, so I want to sneak a little bit of that visual design into the input syntax, just to give the end user sort of like a preview or a feeling of what the graph would look like rendered. I don't want to rely exclusively on the IDs to link individual steps, because that would be very difficult to visually parse to humans like you and me. And I'm hoping to come up with something easier to parse. How to distinguish those two? Just a break, I think. Well, ID should always be optional. Because we might not have to link to that block. ID optional block name. The parser or the interpreter should be smart enough to figure out that this is a fork. And to implement what I have defined with this syntax, this would have to be lorem ipsum with ID 5. Oh no, that's option 2 still. And this is 6. I'm not really sure how I forgot what I wanted to say. Oh, I'm curious how the silhouette diagram would look like. But I believe it could just be a fork. I'll just leave a comment here. Silhouette. But this is not looking bad. Cleaned up, it would look something like this. Start. And then finally end. It's not too bad. How to distinguish a fork from a silhouette? For now, let's do 3 plus options. It needs to have 3 plus options. And I think this is good for now. Okay. Hmm. Okay. So now I've done some research, very high level, and about writing an interpreter in Haskell, um, and it looks like there are many tools already available for it. Not that I'm surprised, but of course there would be. But one of them is called Alex. So I think there was an article here how to use it. Right. So this is exactly it. So this is a tool that generates lexers or lexical analyzers for your code. So I think it would be a good exercise for today, just to do Hello World lexer with Alex. That was quick. Oh, this is probably going to take a little while. Okay, so that would be a good time to take a little break. I'll read through it, let this update, and we'll continue in a minute. Okay, I'm back. It looks like this is installed now and updated and it works. And I took a look at both this documentation and also this article. And just not to take too much time today, this can be a deep rabbit hole. Let's try to just replicate what they have here with their Hello World lexer. We won't need our lexer to look exactly like this. but we can start with it. So I'm just going to copy the code for now. This is it. And let's try to generate code out of it. That was fast. And it's here. Very interesting. 1,500 lines. Seems to be working. It probably won't build, but it did. That is great. But for now, I think it would be a good time to stop for today and do a little bit of research around this Lexer input file and what our simplified Dracon syntax might require. So, thanks for your attention today. I wish you all a fantastic day ahead, and I'll see you next time. Take care. Bye.